When did oceans form on Earth? Part 2. Analysis of oxygen isotope ratio in zircon can address the nature of the reservoir of oxygen in the magma that is adopted by the zircon during crystallization. In other words, 18O, zircon, provides a reliable record of whether the parental 18O magma was mantle equilibrated, as all primary mantle-derived magmas are prior to interaction with crustal materials, or whether the parental 18O magma was crustal, meaning that the magma inherited a component of its oxygen budget from assimilated crustal materials, like sediments or other altered rocks, which results in higher 18O values in the bulk rock and constituent igneous minerals. To address our question of when oceans first formed on Earth, we can investigate the 18O values of the ancient zircons to see if they record mantle equilibrated values, meaning no evidence of a crustal component is detectable in the oxygen, or if they record crustal 18O values, meaning that the early magmas assimilated crustal materials that were affected by low temperature interaction with water prior to melting. Because we can also date the zircon grains, we can place these conditions in a temporal context. What we find is that the oxygen isotope ratios, 18O, in the oldest tetrahedral igneous zircons record mantle equilibrated values from 4400 to 4325 Ma, for example 5.3 to 5.4. From 4325 to 4200 Ma, the 18O values of zircons are slightly elevated up to 6.3. Note, the upper end of this range, 6.3, is higher than what is capable of being produced in a mantle melt. However, the uncertainty in these analyses overlaps with the mantle. Just after 4200 Ma, the story changes. Values of 18O in the igneous zircons reach values as high as 7.3 with uncertainties that exclude a mantle source. We infer that to produce these high 18O zircons required that the igneous protolith of the zircon must have assimilated or remelted crustal materials that were altered by low temperature processes at or near Earth's surface. In other words, surface waters were present by at least 4200 Ma. What does all this mean? There are now two hypotheses for when oceans originated on Earth. Hypothesis 1, oceans first formed at California 3800 Ma. The ISU-ABIF provides definitive ground truth that surface water was indeed stable at 3800 Ma, however no boundary condition can be defined by the ISU-ABIF. Simply put, there is no way to determine if the ISU-ABIF was deposited in the first ocean on Earth. In that regard, the ISU-ABIF is akin to a geologic snapshot. We can't infer that water existed before the ISU-ABIF. Hypothesis, oceans formed much earlier by at least California 4200 Ma. The Jack Hills tetrahedral zircons provide an actual timeline that records the magmatic oxygen isotope compositions of magmas on the young Earth. In this record, we can see a time before the influence of low-temperature weathering was recorded in magmas prior to 4200 Ma, and a definitive change in magmatic oxygen as recorded in elevated 18O zircon after 4200 Ma. In this regard, the tetrahedral zircons actually record a boundary condition that marks when surface weathering, and hence the presence of oceans, occurred.